Hey everyone, it's that math magician, and on this video we're going to take a look at a shortcut for solving sides for a right triangle, and more specifically for a 45-45-90 right triangle. So let's dive in on this video, introduce what that shortcut is, and how we can use it to help us solve for some unknown sides. Now I have an example here of a right triangle which has 45 degrees, and our 90-degree angle. Now you might not remember this, and it's okay if you don't, but because of the fact that they have two angles that match, they both have the 45-degree angle there, this is actually an isosceles triangle. Actually, an isosceles right triangle. And you might remember that an isosceles triangle has two sides that are equal and two angles that are equal. And so for this, we see that because those two angles here open up at a 45-degree angle, that their corresponding sides are going to be equal. More specifically for this right triangle, the corresponding legs are going to be equal on this right triangle. So whenever you come across a right triangle and you see a 45-degree angle, you know that those two legs that make up the right angle, that they're going to be equal. Now another fact about these 90-degree triangles is that we can quickly find the hypotenuse as well. Now you could just take those values of the legs and plug it into Pythagorean's theorem and solve for the hypotenuse. But if you can remember this, that is that the hypotenuse will always be the leg, in this case x, times the square root of 2. No matter what type of 45-90 right triangle you come across, that hypotenuse and the legs will always have that relationship, no matter what. Now let me show you an example problem of how we can actually use this shortcut to help us solve for some missing sides. I'm going to go ahead and paste a copy of that right triangle right there. I need to add in the fact that there is a 45-degree angle in this right triangle. And let's say that I know that this bottom side here has a value of 11. And the question says we want to find the missing sides of this right triangle. Well, because of the fact I see this 45-degree angle here in the bottom left corner, that automatically means that this other angle at the top is also 45 degrees. Remember, all the angles in a triangle need to add to 180. And 45 and 90 add to 180. So, looking at my diagram on the left, I think I can use my shortcut to help me solve for this missing side here of A and this missing side here of B. Now, if we really wanted to, we could probably use sine, cosine, or tangent to help us solve for these sides. Hopefully we feel comfortable and confident enough with sine, cosine, and tangent to do that. But what's nice is that now we have a shortcut and we don't need to do all that work. Instead, we remember that for a 45-90 degree triangle, that our legs are always equal to each other. So since I already know that the bottom leg here has a length of 11 units, then I automatically know that the other missing leg, A, equals 11 units as well. And just like that, we've solved for A. No work required, just using that shortcut for our 45-90 triangle. Now we want to solve for B. And to solve for B, all we have to do is take our legs, which our legs here are 11, and we just have to multiply that by root 2. And we see again that that hypotenuse is length is 11 root 2. And that's it. That's all the work that's required. You're probably thinking to yourself, what? How can that be? But because 45-90 triangles have this relationship, and we remember that relationship, there's no need for sine, cosine, tangent. There's no need for Pythagorean's theorem. If you can just remember that those two legs will always be the same length, and the hypotenuse is just the leg multiplied by the square root of 2, then you are good to go. I just want to make also a quick note You do not need to get the decimal number for this. Leave it in radical form as 11 times root 2, and you're good to go. It's that Math Magician, and I'll see you on the next video.